This episode of Photonics Hot List is brought to you by Aerotech, precision motion control and automation. Take control, speed, precision, performance.
Hello, I'm Justine Murphy with Laser Focus World. Let's take a look at some of the amazing things happening in photonics. Oil spills threaten the health of our oceans, the life within those oceans, and the sensitive environments, including beaches and wetlands that surround them. Chemical dispersants are a common means of cleaning such spills, but they've been known to make the problem worse. Now, researchers have discovered a non-toxic solution in the form of cork. During a completely unrelated femtosecond laser processing experiment, a team of researchers led by Central South University in China discovered the wettability of cork, a natural eco-friendly material, gains both water-repelling and oil-attracting properties. In further testing with a fast-pulsing laser, the cork surface at the micro and nano levels became rougher and much more water-resistant. This allows the cork to collect oil rapidly without absorbing water, making it possible to later extract that oil and potentially reuse it. Deep grooves in the cork's surface boost the material's photothermal properties as well, which ultimately lowers its viscosity for easier collection. The collaborative team is now working to create an oil recovery system that also incorporates polyurethane foam, another absorbent material. We've all had goosebumps on our skin, whether in a defensive reaction to a frightening situation or the natural response to cold temperatures. Now, researchers have found their properties could actually benefit applications in the bio and industrial realms, and potentially even artificial intelligence. A team from the Max Planck Institute for Intelligent Systems in Germany has developed a synthetic system to essentially emulate goosebumps. It involves microactuation, which is the precise control and manipulation of small-scale mechanisms used in things like biomedical devices and robotics. The new system also uses a liquid crystal elastomer, or LCE substrate, known for its responsiveness, onto which a precise array of passive microhairs is 3D printed. A femtosecond laser then actuates those hairs. The researchers say the LCE substrate undergoes a pneumatic to isotropic phase transition, in turn forming elevated bumps and microhairs similar to goosebumps. This synthetic system shows promise for practical applications, such as fabrication of micromirrors designed for precise control of light reflection, as well as small-scale soft robots and technologies that blend both artificial and physical intelligence components. A first-of-its-kind metafluid, complete with programmable optical properties and the ability to easily transition between viscosity states, could revolutionize things like energy conversion, robotics, and shock absorption. Created by researchers at the Harvard John A. Paulson School of Engineering and Applied Sciences, the new metafluid uses a suspension of small elastomer spheres, between 50 and 500 microns in size, that buckle under pressure and radically change properties to flow and adapt to the shape of any container. The team says their metafluid is a conventional liquid containing a suspension of gas-filled elastic capsules. When those capsules are spherical, the metafluid's viscosity changes in response to temperature. When the capsules collapse, the viscosity changes in response to force. The metafluid also involves a highly deformable hollow shell, which makes the fluid even more programmable and compressible. The thermodynamic, optical, and rheological properties can all be tuned as well, and it can automatically adapt to different circumstances. And that's your Photonics Hot List. Be sure to like and share, subscribe to our YouTube channel, follow us on social media, and visit laserfocusworld.com for the latest and coolest news and information. Until next time.